Power of a quotient rule. So power of a quotient rule means that there's a quotient, a division, that is placed to a power of, or has an exponent. When a quotient is raised to a power, distribute the exponent to the numerator and to the denominator. So numerator and denominator. So the a will get distributed to the x and to the y. So let's do example number 1. We have 4 divided by 5 to the power of 3. So now will be 4 to the power of 3 divided by 5 to the power of 3. Let's look at example 2. Here we have an exponent, but within the brackets there's division, a quotient. However, the division has a product. So you still have to follow other power rules when applying frequently the quotient, the power of a quotient rule. So we'll distribute the 2 here. I'm going to zoom in a bit so it's bigger. So the 2 will get distributed to the 3, to the x, and then to the 7 in the denominator and to the y. So it is 3 to the power of 2, x to the power of 2, divided by 7 to the power of 2, and y to the power of 2. Let's look at example 3. Here we have a power to a power. So this power will get distributed to the numerator and to the denominator. However, there's a power in here, which means you have to apply the power of a power rule. So it is x to the power of 2 to the power of 3 divided by y to the power of 3, that's your base, to the power of 3. So notice that the exponent of 3 here is distributed to the numerator and to the denominator. Now to further simplify it, we're going to apply the power of a power rule to further simplify. So this is now equal to x, 2 times 3, divided by y to the power of 3 times 3, which is equal to x to the power of 6 and y to the power of 9. So there are 2 things to sort of mention here that I've just mentioned. The 2 is that if the numerator or denominator is a product, such as here, the product is 3x, ensure to also follow the power of a product rule. And for the third one with a star, if the numerator or denominator has a base that is raised to a power, ensure to also follow the power of a power rule. So let's look at some examples. Example number 4. Simplify the following exponential expressions applying the exponent rules, then evaluate. So we have here 2 divided by 5 to the power of 3. I'm going to zoom in. So the 3 will be distributed to the 2 and to the 5. So it is equal to 2 to the power of 3 divided by 5 to the power of 3. And the question did ask us to evaluate. So 2 to the power of 3 is 8 divided by or over 125. Let's look at B. The 4 will be distributed to the 3 and to the 4. So it is 3 to the power of 4 over 4 to the power of 4, which is equal to 81 over 256. Now we'll look at example C. So here we have a product. So we have an exponent, quotient, division, but within the brackets there is a product. So we have to apply the 3 to the 4, to the A, and then to the 5, and to the B. So that is equal to 4 to the power of 3, A to the power of 3, over 5 to the power of 3, B to the power of 3, which is equal to 64, A to the power of 3, over 5 to the power of 3 is 125. B to the power of 3. So I'm going to scroll to question D. So it's very similar to the one we just did. Now let's look at example E. It's a bit different because we have a power within the brackets. So part of the base that the 3 will be distributed to has a power, which means power to a power we have to multiply. And the same thing for the denominator. So it is equal to x to the power of 4 to the power of 3 over y to the power of 2 to the power of 3. Notice the 3 is distributed to both the numerator and the denominator, which is equal to x to the power of 4 times 3 is 12 over y to the power of 2 times 3 is 6. So question F is similar, it's just further practice. So we'll move to the next question. We have G. So what's different about this one is that there is a coefficient and a variable that is placed to a power. So the 3 will be distributed to the 2, to the V, to the 3, and to this 3. So that is equal to 2 to the power of 3, V to the power of 2 times 3, over 3 to the power of 3, W to the power of 3 times 3, which is equal to 2 to the power of 3 is 8, V to the power of 2 times 3 is 6, over 3 to the power of 3 is 27, and then W 9. For question H, when you examine it, what we have to notice here is that there is a negative. That is a bit different. So you have to make sure that when you do distribute the 2, that you keep the negative 2 in brackets. So we have negative 2 in brackets to the power of 2, and then s to the power of 2 times 2, over 9 to the power of t to the power of, whoops, just rewriting the question here accidentally. So the 2 also gets distributed to the 9 and to the 5. So it is 9 to the power of 2 and t to the power of 5 times 2, which is equal to 4 positive 4s to the power of 4, 81, t 5 times 2 is 10. Looking at question I, one thing to notice here is that there's an exponent of 3, and we have a numerator, and then we have a denominator. But when following the rules of BEDMAS, we do brackets first and then exponents. So if I start with what's within the brackets, we're going to first see if we can simplify anything. And here we can see we have coefficients. We have the variable m, that's the same. We have the variable n, that's the same, to the power of 3, which is equal to 2 over negative 3, and then m to the power of 5 minus 3 to the power of n, 4 minus 2, close the brackets, to the power of 3, which is equal to 2 over negative 3, m to the power of 2, n to the power of 2, to the bracket of, to the power of 3, which is equal to, I'm now going to distribute the 3 to the 2, to the 3, then to the 2, and to the 2. So it is 2 to the power of 3 over negative 3 to the power of 3. And then m 2 times 3 is 6 and 2 times 3 is 6, which is equal to 2 to the power of 3 is 8 over negative 27, and then m6 and n to the power of 6. And I'm just going to box the final answer here so you could see it better. Is the final answer.